So AI today can now match human intelligence in terms of object recognition, outperforming humans in games, like you said, AlphaGo and, Atari. It can now create great paintings using neural art, can talk precisely like humans in the same voice, and more of that kind of stuff. So, however, there are a lot of things that AI still needs to match the human intelligence. So then, how does neuroscience help in doing this for AI?
I think it's a very good question. I think you can imagine like all of these tasks you just mentioned, like vision-based tasks and or audition or speech-based tasks, and all of these are the tasks that we understand very commonly because there is a lot of applications to it that we use. We do these tasks in our day-to-day activities, and since we do it on day-to-day activities, our brains are actually tuned to these tasks as well, and our neurons are actually tuned to actually perform these tasks as well.
Right.
Now, you can imagine like there are some tasks in which AI is already performing or outperforming humans, where especially for tasks where you need to actually train from a large amount of data sets to be able to make predictions, especially from complex data sets, to be able to make predictions, right? For instance, one of the examples that I gave earlier was, let's say if you want to diagnose a certain disease by looking at some information of a patient's file, right? And this today is done by, a very trained diagnostician who actually have seen thousands and thousands of similar cases in his or her life and then be able to make a prediction, right?
Right.
Now, with AI today, you can actually take that doctor's data as label and then hundreds of other similar doctors' data and then train a powerful model, which can, in theory, definitely outperform a single individual medical diagnostician, right? And in that sense, I think AI is already very smart and it doesn't need much sort of like motivation from us or from neuroscience to actually be able to become more robust. But there are some other tasks, several tasks in which help from neuroscience can definitely come very handy. And one of those tasks is, for instance, now there is a lot of problem of like that these models are data hungry. Right? They need millions of examples to actually make a single prediction.
Right.
And now the question is, how many examples do we need to actually classify a face, right? Chances are that we do not need much examples to actually classify a face as a face or a car as a car or, or a water bottle as a water bottle. And then there is this new emerging field, which is in deep learning called self-supervised learning, which is just take minimum examples, right, for supervision, and then itself the model can learn from the data to actually be able to make nice predictions, right?
Right.
And in that sense, and there is another field, which is the subfield of this, which is called one-shot learning or zero-shot learning, where you only need one sample from a different data to be able to make like robust predictions, a human-level prediction, let's say, for a new task. And zero-shot learning is even progressive, which means you don't need any examples, as a label data, and you can still outperform for a new task through a network.
Right.
In that sense, I think we humans are pretty good at, right? Because let's say we have driven a car in a street in London, and then we actually go to drive in a street in, let's say, New York. I don't think we need to take so many examples to be able to actually drive a car. We will just naturally start doing it. And in that sense, I think, so we are very good in this sort of like one-shot learning, zero-shot learning, right? Because we have learned from a specific data modality, right? Let's say from experiences from our driving in London. And then we can actually apply directly to a new task, which is similar task, but with a very different data modality, let's say, relatively. Now, in that sense, I think there is quite some work that is happening in AI, which is like domain adaptation, domain generalization, for instance, where you try to actually take data from multiple domains for different tasks and then try to generalize your models, right? Now, our brains actually are pretty smart in making those amazing generalized features, right? Because when we learn from our environment or from our, let's take vision as an example, we actually, our brains are pretty good in learning some generalized features, right? And if we take that learning principle as an inspiration and try to mimic that into sort of like artificial neural networks, then chances are that we do not need many examples to train a model. Right? We need just a few examples, or maybe like we can lead towards zero-shot learning, right? That is one large example of where AI could be benefited. And then there are several other fronts, I believe. We can keep talking about it. But for instance, on top of my head, one amazing task that we humans are able to do perfectly, which AI is catching up on, is be able to actually take multiple modalities of data simultaneously and process it to make a decision. Right. So, for instance, we take the vision as an input, we take audition as an input, we take olfaction as an input, and other sensory experiences, and then we are able to make some very smart and robust decisions in real time. Whereas when it comes to AI, then you need to make a dedicated model for each different data modality, and then try to make like an ensemble network of these, and then make a joint training of these networks by having a labeled data which has an olfactory score, which has a vision score, which has such data sets. I don't even know if they exist actually, by the way. So making such data itself is a problem, let alone try to benchmark on those tasks. I think their neuroscience could be taken as a huge inspiration, right, for multimodal data sets. And I think our brain is very perfect if you think about several tasks actually. And as I started answering your first question was, that back in like 60s, some neuroscientists discovered some kinds of cells which today are the basis of these deep neural networks, right? And I think they just scratched the surface of the brain. And you can imagine, like, if you just scratch the surface of the brain, then you can have like a multi-trillion-dollar industry standing today, which is AI. And what happens if you scratch it a little more,